All right, so this is your video for page 133, the notes on how to sketch a graph after solving. So these two equations I just picked, so if you want to write these here and here, those are the equations that we're going to use in order to practice. So the first thing we need to figure out is what is the correct method that we need to use to solve. So right now, the only two methods we know how to solve for polynomials is GCF factoring or factor by grouping. They look distinctly different, and you cannot use them interchangeably. So you should have a pretty good sense of which one uses which method. For instance, if we look at number one, there is no way that we can use GCF because there is no GCF in each of these terms, right? There is no x that I could take out because there's no x in this last term. There is no greatest common factor besides 1 for all of these terms. So there's no way to use GCF factoring. That means that we have to use factor by grouping. So then what we're going to do is we're going to figure out what those factors are that we need to graph. So I'm going to go over here and I'm going to make y equals 0, which will allow me to solve for x. And we already said that we're going to factor by grouping. So to do that, we group our first two terms together. So this is x cubed minus 3x squared. We put a plus sign in between and we bring this negative 4x as a group. So now, between x cubed and 3x squared, I have a GCF of x squared. So then I bring that x squared to the outside. That would leave me with x minus 3. Then between negative 4x and positive 12, my GCF would be 4. However, because I want this to be a positive 1x minus 3, my GCF is going to be negative 4. That way, when I divide out a negative 4, I'm left with 1x minus 3. Because the only way factor by grouping works is if these two terms match. Right? So then once these two match, right, that means each term has an x minus 3 in it that I could factor out. So when I factor out that x minus 3, that leaves me with an x squared minus 4 that's left when I factor out that x minus 3. So then when I set that equal to 0, I can solve that equation. So I'm going to set them both. I'm going to move it over here. I kind of ran out of room. I'm going to set x minus 3 equal to 0 and x squared minus 4 equal to 0. So when I solve this one, I get x equals 3 as one of my x-intercepts. So that means 3, 0 would be an x-intercept, right? When y was 0, we got that x was 3. Then if I solve this, I set this equal to 0. I have x squared equals 4. When I take the square root of both sides, remember when we take the square root of an x squared, these will cancel, but that leaves me with a plus or minus answer. So the square root of 4 is 2. So that means one of my solutions is positive 2, meaning that it has an x-intercept at positive 2, 0. And one of my solutions is negative 2, meaning that I have another x-intercept at negative 2, 0. Right? My solutions, what I get for x, are my x-intercepts. Those are the values that I'm going to graph. So I could graph those right now. I have a 3, 0, a 2, 0, and a negative 2, 0. So that's the beginning of our sketch. So then the next part I want to go over is finding that y-intercept. Remember, to find the y-intercept, we just make x equal 0. So if I go to this original equation, I'm going to make all of my x's equal 0. So I'll have 0 cubed minus 3 times 0 squared minus 4 times 0 plus 12. Well, that's going to give me 0 minus 0 minus 0 plus 12. So y equals 12. So when x was 0, y was 12. So I can also graph that point. That's a little harder to do on this graph because there is no 12, but it's going to be roughly right there. So for right now, those are the only pieces that we can find of our graph. As we go forward in this unit, we'll find other ways to be able to get more information. But to really sketch this graph, we're going to use our graphing calculator. So I'm going to type in this function into my y equals. So I hit y equals and I'm on this screen. So then I get x cubed, x to the third, minus 3x squared minus 4x plus 12. So I typed my function into my calculator. Then when I hit graph, my graph is getting a little cut off over here. So I'm going to go ahead and change my window of my y max, right? I'm not seeing enough y value. So I'm going to make that y max, let's just say 15 and see if that's enough. Good, so now I can see that top of that picture right there, right? This is a relative maximum. We'll get into that, what a relative maximum is in this unit, but I can see the top of that picture. So now I can roughly sketch what my graph looks like, right? We already have these x-intercepts drawn, and we already have this y-intercept drawn. So really all we wanna do is make sure that it mimics this picture. So it starts under here, it starts down below, goes through this x-intercept up to the y-intercept, and then back down and curves through both of these before going back up. So remember, this is just a rough sketch. We're just trying to figure out how we go through these points correctly in order to sketch our graph. So then once our calculators helped us with our sketch, we can, of course, talk about our end behavior, right? Our end behavior is where is our graph going at the end. So as x goes to infinity, as we approach these positive x values, my graph is heading up for the rest of this function. So that means its y values are going to go towards positive infinity. As I go to the right towards positive infinity for my x values, my graph is going up towards positive infinity. As I go to the left towards my negative x values, my negative infinity x values, my left side of my graph is going down, right? As my x values go towards negative infinity, my y values are also going towards negative infinity, are going down. Good, so let's look at this next example. We're gonna just go through this same process in order to help us sketch the graph, right? We've already gone over how to solve and get these x values in previous videos and in class. This is really just to give us a sketch of our graph in order to talk about our end behavior. So if I look at number 2, again, I just picked these problems. So for you guys, you don't have to, I just picked these. That's where they came from. So I know from here that I have a GCF that I could factor out of each of these terms. I also know to do factor by grouping, I need 4 terms, right? So I can group the first 2 and group the last 2. I don't have 4 terms here. I only have 3, so I could not use factor by grouping. So this is GCF. So now I'm going to make y equals 0 so that I can solve. So for our GCF factoring, we always divide out our GCF first. So my greatest common factor between these 3 terms would be x squared. So I bring the x squared to the outside, and then what I'm left with, x to the 4th divided by x squared would give me x squared. 3x to the 3rd divided by x squared would give me 3x, and then negative 4x squared divided by x squared would give me minus 4. So now I've divided out the GCF, and this is something that I could factor, right? What multiplies to give me negative 4 and adds to give me positive 3 would be x plus 4 times x minus 1. So now I can solve for these x-intercepts. So I have x squared times x plus 4 times x minus 1. So I'm going to set x squared equal to 0, x plus 4 equal to 0, and x minus 1 equal to 0. Don't forget that GCF that you divided out is also going to be set equal to 0. So I'm going to set x squared equal to 0. When I take the square root, normally I would get a plus or minus, right? Anytime you take the square root of x, you get a plus or minus answer, but there's no such thing as a positive and negative 0. 0 is just the only value that can be. So this is the one exception to having a plus or minus. Any other number, you'd have a plus minus except for 0. So then if I solve this, I get x equals negative 4. And if I solve this, I get x equals positive 1. So that means my x-intercepts are at 0, 0, negative 4, 0, and 1, 0. So 0, 0, negative 4, 0, and 1, 0. So I graphed those x-intercepts. So now, again, I need to find the y-intercept. I do that by making x equals 0. So I always go back to standard form because it's just easier to work from the standard form. You can make the factored form, make all these x's 0. It just takes more computation. So I always just go back to the standard form and make all my x's 0. So then I have this, right? 0 to the 4th plus 3 times 0 to the 3rd minus 4 times 0 squared, which is just 0 plus 0 minus 0. So my y-intercept when x was 0, y was 0. And we already have that point graphed because it's also an x-intercept as well. So now I have my x-intercept graphed and my y-intercept graphed. So now I'm going to use my calculator. So going back to that calculator, I'm going to go to my y equals, clear the old one, and I'm going to type in my new function. So x to the 4th plus 3x to the 3rd minus 4x squared. And I'm going to graph that. Let's see if it shows the whole picture. All right, so it looks like I'm going to have to zoom out a little bit because I'm missing this chunk. So that means my y value is not low enough. So if I go to my window, I want to make now my y min a bigger number. So I'm going to make this, oops, this was going to say negative 10. I'm going to make my y min negative 20 and see what I get. So see, I can still see where both ends of my graphs are heading, but I can't see the bottom of this. And so when it comes to sketching, we just want to see, we want to get in the habit of making sure we can see all parts of our function. So I'm just going to make that negative 30 instead to see if it, and we're almost there. So I'm just going to make it negative 35, and I think we'll be good. Right, this is how I do my window. I just keep testing until I really think I get a sense for what the graph looks like. Man, one more time, make it negative 40. All right, there, now I can see the bottom of that graph. That's obviously going to be hard to graph on this one just because this only goes to negative 10 on my paper. But again, this is a rough sketch, and what we really want to make sure is that we're going through our x and y intercepts. So what we see is we start above, we start at the top, and we work our way down. So we're starting here. What you are going to learn, and what we'll go over later, is anytime you have an answer twice, which would have been here at x squared equals 0, right? This means 2x's equals 0. So technically you have 2x equals 0 answers. Normally, if you think about a plus minus, that's kind of the idea of having those two answers, one positive, one negative. But since it's 0, you just have two zeros. Anytime you have an answer twice, it's going to bounce at that value. So you can see, and we could zoom back in to see this if we wanted. If I hit zoom 6, we can see that when my graph comes back up, it doesn't actually cross through 0. It's going to do what we call bounce at 0. So it's going to come up to 0, and then it's going to go back down. So it's not actually going to cross through the point. It's going to bounce, come down, and it just a really little down before it goes through the other point at 1. So that's our bounce, and then it goes up. So what we see from our sketch, and again, it doesn't have to be perfect, it's just a sketch, but we want to get an idea of where it goes through those x and y intercepts, and then where it's ending up, where those end behaviors are. So we can see that our graph keeps going up in both directions, so we want to make sure that we have both arrows pointing up in both directions. So that's going to determine our end behavior as well, right? Because as x goes to infinity, as we're going this way, my graph is heading up, so that means it's going towards positive infinity. And as x goes towards negative infinity, as I work my way this way, my graph is also going up, which means it's going towards positive infinity, right? Both of your ends are pointing up, which means both of your end behaviors are pointing up to infinity. So hopefully that was a good little review of solving, but then how we can use solving and finding that y-intercept to help us sketch a graph. And what we're going to spend a lot of this unit is finding more pieces to our graph to make an even more accurate graph. But for now, we're just going to focus on that x and y intercept, which then can help us sketch the graph and tell us our end behavior. So your homework is to do pages 134. So you'll need to write down these two equations. Yeah, for 134, you're going to use these two equations to help you. You're going to solve them, find the x-intercepts, the y-intercepts, sketch the graph, and then determine the end behavior. So that's x to the third minus 5x squared minus 1x plus 5 for 3, and then x cubed minus x squared plus 16x for 4. So go ahead and work on those, and then check your solutions when you're done.